purpose of this video is to work with properties of exponents. First, we'll introduce or review the idea of the exponent. In our general form, it's any base value, either a variable or a number, which represents that, to a power. So the value of n is we refer to the power. Some people refer to as the exponent. B is the base. As an example, if we took a base of 4 to the third power is how we read that. Just remember that that means that we're taking 4 times 4 times 4. We'll look at some properties as they relate to these exponents. First off, the product property. General form for the product property is a to the nth power times a to the mth power. Those could be any numbers, any values, and for now we're just dealing with positive numbers. Notice we have the same base. A is in place of the base, and what we will do is we will add those exponents. So that's our general form. Make sure that you have that written down as far as the general form. Now, when we look at this value then of the first example, x to the fourth times x to the sixth, that is equal to x, we will add the 4 plus 6, which gives us x to the 10th power. And understand why that works, because x to the fourth, if we remember our exponents, and you don't need to write this down, but x times x times x times x, that's x to the fourth power. Also, we have x to the sixth power, which means we have 1, 2, 3, 4, 5, and 6 of those. So if we were to add all those x's up, notice we end up with 10 of them. As a shortcut on this product, where we're multiplying these two, they have to have the same base, we will add up the exponents. We can do the same thing with a base that is an actual number. 5 squared times 5 cubed, or 5 to the second power times 5 to the third power, we can add those exponents up. That would be 5 to the fifth power. As we take 5 to the fifth power, we could also write that down as 3,125, because that's the equivalent of 5 times 5 times, we have 3 of these 5s, 5 times 5 times 5. Altogether we have 5 of them. So 5 to the fifth power. In this case, because it is a number that we have a constant, we could write the actual answer if we multiply that 5 times, and that is 3,125. Last example on the product property, we have the same base of n, that is the variable n. We don't know what that number is, but that would be equal to n to the 5 plus 7 is equal to n to the 12th. As we go on to our next property, so we have our product property. Our next property, the quotient property that we'll use. Notice the difference here between the quotient property and the product property is we have the same base still. It is a fraction, which is division, and that's why it's called the quotient property. But in this case, notice in our general form, please write this down, a to the m power divided by a to the nth power is equal to a to the n minus n. So we'll subtract those exponents. In this case right here, x to the sixth divided by x squared becomes x to the 6 minus 2, which is equal to x to the fourth. Understand how we get that? X to the sixth power, I'll write off to the side, is 6 x's, remember? And we'll divide that by x to the second power, which is 2 of them. And you can divide out from numerator to denominator. Notice I'll circle this here. You're left with 4 x's. Very quickly, 9 to the fifth power divided by 9 cubed is, we still subtract 9 to the fifth, 9 to the power of 5 minus 3, which is 9 squared. In this case, 9 squared also could be written as 81. On to our next property. We have the power of a power property. So on this one, notice the example, we have a to the nth power, that quantity taken to the nth power. And what we do is we take the product. So notice that m times n right here, we're going to be multiplying. So here, that is actually a product we're doing. So what that means is this x to the 5th power cubed is x to the 15th. And understand why that works. We just took the 5 times the 3 to get our 15 as we underline that. But x to the 5th power, understand, if we're taking 3 of those, x to the 5th powers, that's really this.
I need Andy O'Dell to the office, please.
So notice 5 plus 5 plus 5 is where we get the 15. So we end up with x to the 15th power. Second example, or next example, example number 7, 2 cubed squared, we would take and get 2 to the 3 times 2, or 2 to the 6th power. 2 to the 6th power means we're multiplying 2 6 times. That does happen to be 64. Moving on to our next example. This is referred to as the power of a product property. Here we're multiplying two terms within the parentheses, but we're taking them to a power, both to the same power. Notice what happens. In this case, we have the a and the b, those variables. They both are taken to that power. What that means in this case, x times y cubed, because that is x times y cubed. What we would get in this case, when we multiply those, this would be the same thing. This would simplify to x cubed and y cubed, which a way of thinking of that is we have this xy and we have 3 of them. That's an x times y times an x times y times an x times y. So notice we have, as I'll underline him here, we have 1, 2, 3 x's and 1, 2, 3 y's. So shortcut method is using that property. Example number 9, dealing with power of a product property. This becomes, now notice we have a 3 times x to the 4th. This becomes 3 to the 4th power times x to the 4th power. This would simplify since 3 to the 4th power, 3 times 3 times 3 times 3 is equal to 81. We could write it as 81x to the 4th. Moving on to our next example, or next property. On this property right here, power of a quotient property. On this one, notice that we have our quotient, which is a fraction to the nth power. And so the numerator is taken to that power, as is the denominator. So in this situation, following our property, quantity of x over y to the 5th power becomes x to the 5th power over y to the 5th power. Reasoning behind that, we have x over y times x over y, x over y times x over y times x over y. And notice in this situation we have 5 of these x's, 5 of these y's. Last example, 2/3 to the 4th power. Well, that becomes, using our property, 2 to the 4th power divided by 3 to the 4th power. Because these are both constants, we can simplify 2 to the 4th, multiply 2 4 times, and get 16. 3 to the 4th, as we've done before, is equal to 81. Last thing that we'll do with this, and this you need to bring back, you need to do these sample problems. And these are extensions of the properties that we just looked at in this video. And please have these done within your Cornell notes and have back tomorrow.